Hi everyone! Today we are going to create classic solitaire studs, or stud earrings. But this won't be just random artistic modeling by eye. We will build this model according to strict technical standards that I have previously covered in detail in my ProTip 13 and ProTip 14 articles on Patreon. The foundation of this tutorial will be a proper bezel setting and a screw back mechanism, where we will set the exact dimensions for the post and the hole for manual thread cutting. But before we begin, I want to point out right away, these tutorials are not for absolute beginners. You should already have a basic understanding of how the software tools work. This lesson primarily shows my personal pipeline for building a correct 3D model. If I describe in detail every time which button I press and why, the videos will drag on for hours and become boring. And probably boring for me first of all. You need to understand the capabilities of the tool to see in which exact cases to apply them. That's why I show the logic and workflow. And this is much more valuable than talking about buttons you should already know. For those who want to get this model ready-made or study my text instructions, the link to Patreon is in the description, where this video, by the way, was released in early access. And now, let's open jewelcalc.app and get to work. I will generate a 5mm round stone with a cutter and save this asset. Now we can open Nomad Sculpt and load our stone into the program. I'll change the mat caps. Alright, let's move on to creating the setting. I will add a cylinder to the scene. Since our stone is 5mm, I will make our cylinder with a 3mm radius. Then the walls holding the stone will have a thickness of 0.5mm. I'll turn on X-ray to better control the process and adjust the length of the cylinder so that its top is slightly above the table of the stone and the bottom has enough space for the back plate that I plan to make separately. We need to make the length such that the cullet of the stone doesn't hit that plate. I do this by eye because I am sure everything will fit right. We can move on to setting up the hole. With simple math, we determined that in our case, we need to make a hole with a 2.2mm radius, which will give us a 0.8mm wall. I'll increase the polygon count and press validate. I'll place the cutter and boolean out the seat. I'll add another cylinder. This will be the bottom plate. Its thickness will be 0.8mm and its radius will be 2.5mm. I position it using the gizmo at the bottom of the setting. I clone the plate and move the copy a bit lower. Next, we need to boolean a seat for the plate in the setting. I'll return the plate to its place. I clone this plate, and since I still haven't pressed validate, I can easily change the dimensions of this cylinder, turning it into a post, 12mm long and 1.1mm in diameter. I want to change the mat caps to yellow. I'll increase the polygon count of this cylinder. I will make 2 copies of this cylinder because I want to make through holes in the plate. So, keeping in mind the 0.8mm rule, I calculate the dimensions of the cylinders with simple math. If the cylinder is 5mm and we want to leave a 0.8mm thickness, then 5 minus 0.8 times 2 equals 3.4mm. So, I won't talk through all the math and we will just speed up the video. Next, I will work with the trim tool, and first we need to turn on symmetry. I always try to find it visually. This looks right. I will trim it like this. Our task here is to leave enough metal, and I think this will be good. Next, let's boolean our plate with this element. I'll check this dimension. It's about 0.6mm. This is enough, so we can move on. By the way, it's not even necessary to make a post. You can make a mark right here, just ask your jeweler. Maybe a better option would be to make the post manually from wire. As a 3D designer, all you need to do is make a center mark. Then the jeweler will make the wire post themselves and easily solder it right in the center, guiding by the mark you made for them, like this. I won't do this right now because I want to make nice renders, so I'll go a few steps back and keep the post. So now I will boolean the post with the plate, and they will become one single piece. Before starting to work on the lock, I will group everything together. I'll add a sphere to the scene. It ended up in the group, so I'll pull it out. I will flatten and scale it down a bit. I think this looks good. I add a cylinder to the scene. I move it like this and add a radial repeater to it. It's better to slightly reduce this circle and the small cylinders themselves, like this. I'll increase the polygon count of this cylinder. To apply the radial symmetry, I press Validate and boolean these cylinders into one object. Next, using the Trim tool, with none enabled, and the Rect Selection mode, I'll simply cut off the top and bottom of the object. Next, I click on the three dots right here and select Separate Topology. I got a group with two objects. We don't need the center one, so I will delete it. Let's get back to our flattened sphere. I'll lower this piece down a bit. I will also trim the sphere itself. I'll remove the excess like this. I select the Mask tool and mask this part. Go to Settings and set the thickness of this piece to -0.9 mm. I'll delete the excess. And this part I will make cone-shaped like this. I'll mask it and give it some thickness. Next, it is absolutely necessary to do a voxel remesh of both of these parts. Now we boolean them and get this pie shape. But this pie now seems a bit too small to me, so I will increase its size. I'll add a 5 mm reference cube to the scene. This will be our earlobe. I'll raise our pie higher, guiding by the cube. Now the cube can be deleted. Moving on, I will add a new cylinder. With it, I will make a pilot hole. For our post to fit through, we need to make this hole with a 0.6 mm radius. I'll make it a bit longer and boolean it out. I add a cylinder to the scene again and move it down. In the settings, I will temporarily make its diameter 3 mm with a 0.9 mm hole for thread cutting. The length is also important. I'll make it 2 mm so the master jeweler can cut enough threads later. It looks a bit rough, so I think 1.5 mm will be enough. This will allow for about 6 threads for a jewelry bag, which is the perfect balance. I think a 3 mm diameter is also too much, so I'll reduce it to 2.6 mm. The wall calculation is 2.6 minus 0.9 divided by 2 equals 0.85 mm of metal thickness at the thinnest point. So, as you can see, everything relies on math and calculations. Next, using the tube tool, we need to combine these two parts, turning it into a screw back. So let's go. Also, let's not forget about thickness control. Here I enter a radius of 0.45 mm, so that everything is reliable. I will continue tweaking the shape of this element. Now we need to mirror this element to the opposite side. And voila, it is ready. Next, if we plan to print this, we need to separate the parts and delete the stone. As I mentioned earlier, some people find it more convenient to print such earrings without the post. But do not forget in that case to mark the center for the jeweler. But I won't do that. Next, we can press Boolean to get rid of internal intersections. Also, it is absolutely necessary to optimize the model before printing, because for such a simple earring, 1,400,000 polygons is way too much. I will go to decimation to reduce their count. That is much better. We can also check the wireframe. This density is enough for 3D printing. Now we can export the 3D model and see how much it will weigh in Jewel Calc. By the way, in Jewel Calc, right here in the repair center, you can also Boolean objects, thereby getting rid of internal intersections and junk particles. Well, let's press calculate and find out the weight of one earring. I also want to mention that in the repair center, you can split the 3D model by clicking on Split into separate parts. Then press calculate and find out how much each individual piece weighs. Alright, I will return to Nomad Sculpt. I want to make a render. Still, for the render, it will be better to slightly trim the top. You have to understand that modeling for production and for rendering are different. It will be better this way for the render, and we will return everything as it was later. So, here are the stud earrings we've got. Thanks to the correct calculations, the jeweler will easily cut the thread, and the stone will sit in the bezel setting as securely as possible. I remind you that you can download this model on my Patreon. And finally, a special part of this video. I want to sincerely thank my Patreon community. Your support is what inspires me to share my experience, reveal jewelry secrets, and create new content. Thank you to each and every one of you. If you found this tutorial helpful and learned something new today, please hit the like button and subscribe to the channel. It really helps me keep creating these videos for you. You can click on the screen right now to watch my other jewelry modeling tutorials.